Hi, everyone. Does everyone have their calendar set up for their Hype Doc to remind them every week? Okay, so these slides can be found at bit.ly/sniff_ROM if people want to follow along instead of looking up there. I'm also going to pass along the ROM itself and then the game cartridge. So if people want to look at it, go ahead and pass it backwards. So I'm going to show everyone how you can unlock your ROM sniffing superpower. My name is Brad. You can tweet me at Bradical. I'm also a Recurse Center alum. It's a wonderful place where you can learn and grow as a programmer. I'm also a software engineer at Peloton. It's a wonderful and fun place to work. Let me know if you'd be interested in working with me. This is at the end of year party at Recurse Center with two people that I sniffed ROM with, Cameron and Avery. On the right-hand side, that's our ROM sniffing setup that I'm going to go into more. When I was growing up, I loved playing video games. I especially loved Super Mario 3 and Super Mario Brothers in general. At Never Graduate Week, I went to see a speaker talk about ROM or hacking, hardware hacking. So I saw Phoebe speak, and that inspired me to begin to sniff ROM. And here is a diagram of sniffing ROM while the game is playing. So grabbing the data from the game as it's being played, specifically the instructions that are being played by the processor. Let's step back for a second. So what is sniffing? I guess the person that introduced me said that it was like smelling. I guess that's one way of looking at it. Another way of looking at it is you're monitoring data that's coming through on a system or capturing data that's coming through a network. And so if you're on an open network and you can look at all of the different packets that are on that network using Wireshark. Who here has tried Wireshark? Oh, everyone, awesome. Almost everyone, not everyone. So here I was browsing StarCon. You could see the source IP address, and then on the right, the destination IP address. And you could also see StarCon was in the packets themselves. So if someone had been inspecting this, they might have seen StarCon in my packets if they were sniffing my data. And then here is the binary representation of the packets. So ROM. So what is ROM? ROM is read-only memory. So people like to see it as maybe it's written once at the factory. So it's installed at the factory. It's contrasted to RAM, which is random access memory, which loses its data once it's disconnected from a power source. So why sniff ROM? You could unlock all of your favorite Pokemon if you got the ROM. You can find Easter eggs in a game. You can maybe find the map of one of your favorite games. What has ROM? Pretty much everyone in this room has something on it that has ROM, like your computer, your laptop, an iPad, a cell phone, maybe a smart lock, maybe smart speakers, a smart thermostat. All of these things have ROM on them. How to identify it? So there's two different ways. One, you could open up the device, and you could see these black chips. You could read the very small fine print, maybe with a magnifying glass, and then search for that, and then see if it's ROM or not. Or you could go to ifixit.com and try to see if they have information about what is ROM. The green thing in the background, it's a printed circuit board, and then the black components are chips on them. So here we have the ROM of a smart thermostat, and then also a Google Home. So looking at our chip that's being passed around, or our board, we have the chip on the bottom, and it's MN44. That is a possible ROM chip, but if you notice, it's connected to a capacitor, which is a power source. It's also pretty close to a battery, which is a pretty good indicator that it's probably not ROM, that it's RAM, because it needs power. It's volatile. But if we look up a little higher and we search for SNS, we'll find out that that is the ROM. So wonderful. Now we have something to sniff. So the tools that you'll need for ROM sniffing. First, you're going to want to have a sort of microcontroller. So an Arduino is a good device for that. You also want to analyze the data coming off of the ROM. So a logic analyzer, and then wires to connect to your ROM. In the middle, we have our Arduino. And what an Arduino is, it's a microcontroller, or it's a very small computer that's the brain that can be used for prototyping hardware. So in this case, we're using the Arduino to send queries to the ROM. And here's a closer look at the at the Arduino. And in the middle, we have a crystal or a timer, which means that we're able to grab data at a precise rate or send queries at a precise rate. The logic analyzer. This is an old school logic analyzer. I'm not quite sure how to interpret the data, but if we look, we have a more modern analyzer. At the top, we have our USB port. At the bottom, we have 8 pins. And the USB port will connect to your computer, and then those 8 pins will connect to the ROM. Wires. There are 2, and so the wires connect to the ROM. There are 2 types of wires we could use. One, we could use clips, or we could solder the wires on ourselves. The clips can be kind of expensive, so the soldering can be tedious, but that's a much less expensive way to go about sniffing ROM. So using our tools, how do we use them? This is a high level. We connect Arduino to address pins, and then we connect the logic analyzer to data pins, and I'll go more into depth of what those pins are. Up here we have like kind of silver teeth. Those can be called pins, or they can be called leads, and they're on the printed circuit board. If you notice on the top, we have 16 pins. On the bottom, we have another 16 pins. That means we have 32 pins total on our ROM chip. So what to do with these pins? So we'll search Google with the lettering that was on that chip, which was SNES ZL0, and we'll search pin out. And the first result gives us a bunch of letters and numbers. And we're not quite exactly sure how to make sense of these letters and numbers, but we're going to go into that next. So each letter and number corresponds to one of the pins on the chip. All of the letters that start with A are address pins. So we have 20 address pins, and that means that there's 2 to the 20, or about a megabyte worth of, or a million locations that we could store. And also we have an output enable pin. That's used to help with the timing so that we know when to release the data from the ROM. We also have power input and output power pins so that we can power our ROM. And so to put everything together, we have address pins, data pins, power pins, and then our special output enable pin. What the console does, the SNES, is it sends queries to the address pins and then reads the data from the data pins. So what we do is we're going to impersonate the console by the Arduino sending data to the address pins and the logic analyzer reading it from the data pins. Here's the code that's being used for the Arduino. It's a bunch of C code. The outer loop goes through all the addresses, and the inner loop sends signals to the address pins. So here you'll notice the outer loop, we go 2 to the 20 times in a loop, and that's because we have 20 pins total. And the digital write will write to each, this is a writing to each individual pin. So here we're writing to the output enable pin. If you notice, first we write to the address pins, and then we write low to the output enable pin. And then we put in a delay, and then we also write high to the output enable pin. So making sense of the output. So after we've written to the pins, we're at the same time reading using the logic analyzer. And this is the output of the logic analyzer. The blue bar is a moment in time. And here we see time has passed. And the reason why time has passed is because we added that delay. And you can see on channel 7, there's equally spaced curves, and those are because of the delays in the output enable pin. If a curve is high, that represents a 1 in binary. And if a curve is low, it represents a 0 in binary. So we can think of the blue pins or the blue channels as corresponding to the blue data pins. And the yellow channel here on the bottom corresponds to the output enable pin. So we can take the data from our channels or our output pins, and we can convert them first to binary and then to a hex value by reading if they're high or low. And then when we extract the data from the logic analyzer, we have to tell it, please look at the data on the following edge. And the following edge means when we can turn output enabled pin from high to low. And this is the data that we get from the logic analyzer. It's a bunch of timestamps on the left and a bunch of hex values on the right. This is all the value that's derived from the data pins. And we don't really care about the times because we know we dump the ROM in sequential order, in order of time. So now that we have our ROM dumped, let's think about finding interesting data from our ROM. This is the binary, how it looks. It's kind of hard to, it's just looking at it in Emacs, nothing much there to see. But if we run the strings program, which gives us the strings from binary, we can see the Legends of Zelda come out. Next, we want to try to find images or sprites from the game. One way to do that is we know that Super Nintendo games have sprites that are a width of 8 pixels, 8 or 16 pixels. So we put P48, and this is part of the format that's expected for any pixel format file. We have to put this header at every file, and then we just append the PBM at the end of it, and then we're able to open the file as a picture file, and it will show us images. And here is a bunch of images stitched together. So this was after a whole bunch of scrolling through the ROM at an image format. I found the Nintendo logo, and here we can see it below in the game itself. So you can sniff anything you want to, but how do you know what to sniff? You can think about items you have laying around in your home, maybe a piece of hardware that you're interested in or curious about. Then you just Google and you find the pinout for the components after you've opened it up and found the ROM. Limitations. So more modern ROM has smaller pins and a lot more pins and more complicated protocols. So those could be a little bit of a challenge. Also, sometimes data can be encrypted as well. So keep this all in mind as you're sniffing ROM. What else can you do with sniff data? You can find security loopholes. You could edit a video game and play it on an emulator. Here are some really neat resources. So first is a blog post about this ROM sniffing adventure. Next, Exploitee shows some passwords, default passwords for some pieces of hardware. SparkFun, it shows a cool analog sniffing tool that you can use. Radar helps you reverse engineer binaries. And Tom7 wrote a bunch of code that allows you to that allowed him to automatically play Mario games. Scamline also does some cool hardware hacking. And lastly, I want to thank the people that did this hardware hacking with Dettmer and Avery, who are super awesome. Phoebe for sharing her presentation. Speak Code for inspiring me to do this talk and letting me do the very first incantation of it. And my company as well, Peloton, for being awesome. And the Reeker Center for being a wonderful community. And Avery for sharing her hardware hacking expertise.